So in this ending and bonus video, let's talk about OOP and understanding advanced OOP as it relates to if you decide to pick up a programming language. I'm not going to get into the specifics again of how, but I want you to understand a basic concept of what this is, and so that if you are interested in it, that if you knew this or know this going in, it will make your introduction into programming that much easier because you're kind of already got a jump start on what to expect, and specifically, generically, how to talk about or how to understand OOP. So first we needed to kind of define what exactly is OOP. And OOP is object-oriented programming. And specifically, this is referred to typically as what's called classes. And so we create classes, and classes are almost like a function, right? The way that you structure a function in that it takes parameters and you do additional things like give it properties and things of that nature, but that's starting to get into the nitty-gritty, and I don't want to get that far low. But I do want to talk about two high-level concepts with object-oriented programming, or OOP, and that's abstraction. And this other one is called polymorphism. And so these are like things that make you automatically so scared that you don't want to know anything about it because it's well over your head. And in all honesty, it's not. They're just really fancy names for an idea or a concept. And if you hear it broken down, you may not be so afraid of it and say, you know what, I can understand that. It's pretty simple. Okay, so let's look at abstraction. What exactly is abstraction as it's related to object-oriented programming? Abstraction is basically the art of reducing something to its highest level, not lowest level, but its highest level. Essentially what we're trying to do is, remember in math when you used to have to reduce and reduce and reduce a number to its, to its lowest common denominator or something? So in that regards, it's similar to that, except we're going the other way. We're trying to go to the highest level. Or better yet, in business, we always say, keep it stupid simple, or keep it simple stupid, or however you want to say it. In any event, the bottom line is we want to take something that's complicated and reduce it to its most simplest basic form, okay? And so if we look at, for example, a car, right? That's something very specific. But if we talk about a vehicle could be anything, right? A vehicle could be a car, it could be a plane, it could be a train, it could be a motorcycle, a bicycle, because they're all vehicles. The problem with using vehicle, though, is we can go even more higher than that, because if you use the word vehicle, because you have a lot of experiences of what a vehicle could be and what your personal primary vehicle is, it's subjective to interpretation, right? And so you immediately want to take your brain and resolve it to what you know that's in your experience. So for me, it would be a car. And for most of you, it would be a car. Now, if you're in Europe and you use a bicycle, or maybe you take the train, maybe you would think of that. You wouldn't think of car. But the point is, you're going to really closely relate it with something that you know. So if we go even higher and more generic, we can just call it transportation. Well, transportation, you might argue that you could assume it's the same as vehicle, but transportation's so generic. You almost need to have more information in order for your brain to try to chew and resolve. And as humans, we just want to chew on something and resolve it, and we only can do that based on what we know and have in our experience. So this is the art of programming and object orientation and abstraction as it relates to the architecture of how you're going to make something in code. You want to try to keep things as simple and high level as much as possible, and then break it down so that you can reuse the code again and again and again. And you want it to serve as many scenarios as possible, because the goal here is to write it once. We don't want to have to write the same code again and again and again and again. If we can write it really good in the highest form of abstraction, and then do certain things, what I'm going to show and get into, and I'm starting to get ahead of myself, so I'm actually going to pause here. But I want you to think of abstraction on a scale of, 1 being maybe the vehicle, the car, and the vehicle being, level 5, and transportation maybe being the highest level at 10. All right, so now with that being said, let's talk about this other scary word called polymorphism. And really polymorphism, these are way more complicated than how I'm explaining them, but I'm trying to give you the basics to at least get your head around or get your palate wet and understand what is going on here. So polymorphism, think of it as a template, a blueprint. This is essentially a class. Okay, so if we look at a car, and a car has 4 wheels, and we know a car has 4 doors, and we think of the car as a blueprint, right? So we're not actually making a car, but we're talking about a plan or a template to make a car. We know also that a car has an engine, and a car has top speed, a car takes fuel, a car has a make, it has a model. And so now if we say, okay, well, that's great. So here is our class or a blueprint or our template for car, to make a car. So let's go make a car now. Okay, so here we have a Chevy Impala that's an 8-cylinder motor. It takes unleaded gasoline and it goes 123 miles per hour. Okay, let's make another car from this template. Well, let's make a Porsche. Let's make it a 911 GT3, right? Yeah, those are really cool and sexy, right? 8-cylinder engine there, but we're going to throw some high-test gasoline in this bad boy, and we're going to whip this thing down the street at 197 miles an hour and pray we don't get a speeding ticket. All right, so with that being said, you now know what polymorphism is, right? We took a class, we did something called instantiation, which means to just make an object from the class. In this case, you just saw we made a Chevy and a Porsche out of that base class, or that class rather. And so now if we look at something called overriding in polymorphism, here we have that same template using that car as a blueprint, right? Now everything's fine, but you notice under overriding, I said the car has 4 doors. Well, here's our same Chevy. Nothing's changed. It's still based on the main template, but I want to override what the template said, because the template says my car has to have 4 doors. Well, my 911 GT3 has 2 doors. And so in order to change that, I need to override what the blueprint said it was. And so that's what's called overriding. And so when you practice that in polymorphism and you override something, you're saying, I don't want what is in the template. I need to basically change that and make it my own. All right, and so everything's the same. So now my 4-door car template for my Porsche now has 2 doors because I overrode that. So now let's talk about the same type of concept, but now we're going to overload something. So what does overloading look like? So here we go. We got all of the same stuff, usual suspects in our template. Our Chevy is absolutely identical and the same. Here's our Porsche, and now we're going through, everything's the same, right? Well, what's going on? Why is this so different? Oh, it's a blue Porsche. Oh, wait a minute. And it's a year from 2010. So what did we do here? So we took the base template, right? And the car, we haven't changed it. We didn't override anything that was there. What we did is we overloaded it, which means we've added additional attributes or properties to the template. And so, at this point, now I've overloaded it, and I could create a template for Porsches. If I wanted to keep this as a template as Porsche, I could go ahead and override that. Or what I could do is use this template at the top, and I could just add a car has color, a car has year, right? So now I've overloaded the base template, the original template, and I've created a second template, and now I can take in a color, and I can also take in a year. But I kind of jumped ahead in this example. Again, I'm not trying to get too specific with it because this is a very complicated subject. But in any event, just wanted to let you know about object-oriented programming. I wanted you to know about classes. I wanted you to know about, well, we didn't much talk about inheritance, but in any event, polymorphism and abstraction and how you use all of that stuff. So as you move forward and get into some of the programming languages, one of the things that you may want to think about if you want to write less code is, does the language support object orientation? And if it does, you're going to need to be able to understand or get into these types of concepts. So anyway, this is why this was a little bit more advanced, and I wanted to keep it as such. And as a result, you are now ready to jump off into the low-code, no-code platform and even go so far as to pick up a programming language, and you got now some good 101 basic skills in your understanding. And any course that you take is going to spend half the time to go through what I just went through in the beginning course, you could probably even skip ahead in some areas and just start at the intermediate level in some cases, depending on the language, because now you know the basic ideas of things. But you will need to pay specific attention to the functions that are native to the programming language. You will need to understand what are the ways in which you create a variable. You'll need to learn the language's syntax and how that works. And yeah, for the most part, that's it. That's it for this course as a whole. Thank you very much for taking the time. I appreciate it, and I hope this free course brought some value to you. Thanks. Have a great day.